Hello, Geometry Chapter 8, Test Corrections. We'll start off with question 1. It asks for the sum of the measures of the interior angles of an 83-sided polygon. You'll notice from your toolkit that you have the formula here, n minus 2 times 180. That would give you the sum of all the interior angles for any polygon. Clearly for this problem we want n to be 83, which means I can put 83 in the formula right there and simply polish off the rest of the calculations. 83 minus 2 times 180. The rest is you. Not much left. Number 2, find the number of sides of a regular polygon if one interior angle measures 165. If you would look at the back of one of your toolkit pages, you would see that example that was done where I have it broken down into the hard way and the easy way. Of course, why wouldn't we do this problem the easy way? And that would be, I would take my interior angle of 165 degrees. Remember, that's an inside or interior angle. And from there, it wouldn't be hard to get an exterior angle. You should immediately know how to do that. So let's assume for a second that you have this exterior angle figured out. Well then, finally, you should know that all exterior angles total to 360 degrees. So once you have this one figured out, right, with the star there, then tell yourself, well, how many of those does it take to make 360? And that would take care of number 2. Number 3, what is the measure of each interior angle of a regular 10-sided polygon? Well, a lot of you may have used this formula earlier by mistake, but this one here is the formula for finding one, right? Each interior angle of any regular polygon. So as you can see, we have 10 here, which would be the n for this problem. And just like for number 1, it's basically plugging that 10 into the formula and then working it out. And I'll leave that one for you to finish off. Number 4, find the number of sides of a polygon if the sum of the interior angles is 25, 20. Think about this one as being like a partner with question 1. Question 1 gave you the sides, 83, remember? And wanted the total. Now you're given the total and want the sides. But we're still using the exact same formula that we used in question 1. It's just that this time we wanted the total, well, excuse me, we knew what the total was and we're seeking to solve for n, find n, like algebraically, you know. I'm wondering if I should give you this. A good first step that always seemed to work on this kind of problem was to divide by 180. And I'll just put etc., meaning that, you know, then you finish off the rest of the algebra until you figure out what n is equal to. Question 5. Find the number of sides of a regular polygon if one exterior angle measures 8 degrees. Well, this one connects quite a bit to exercise 2. In exercise 2, we, however, had to find the exterior angle ourselves. But here, as you can see, the exterior angle is just flat out given to us. And as I said before, all exterior angles total to 360. Period. Every time. So if one exterior angle is 8, how many of those would it take to make 360? Simple. Number 6. I give you guys a lot of credit. You really tried hard on number 6, of all these steps that you have to go through. There's a lot involved in these problems, and I was not too disappointed with how these worked out. We want the area of a regular octagon. Notice these lines that I'm drawing into this octagon at first, breaking it into all these triangles. 8 triangles to be exact, as you can see, right? And so if all these 8 triangles here, these 8 central angles, meet in the middle, I know they total to 360, so the first thing I'll do is 360 divided by 8. And when you do that, you get 45. So, picture this triangle right here that I just put the star in as being down, or excuse me, off to the side there, kind of blown up, with this being 45. We just figured that out. And the sides of the octagon are all 14. I know that this one wasn't labeled 14 at first, but they're all 14 all the way around the sides. Okay? Well, what I need to figure out for this triangle is its height. And so that required us to move over and kind of draw a new picture where everything was cut in half. So it's like I'm taking this half right there with the check mark and just blowing it up a little bit bigger. Makes this a right angle. It also makes the 14 become a 7, and it makes the 45-degree angle actually be 22.5. I saw a lot of 67.5s here for this angle, and I don't quite know where that came from, but make sure you're using the right angle as you make your corrections. Now, I told you when you were taking the test that you'd be using tangent, right? Oh, I'm sorry, we could also label the height as x. Sorry about that. Now, I told you that you were going to be using tangent to solve this problem. Well, I just told you what the angle in this triangle is, 22.5. On the board in class, I had the definition of tangent as opposite over adjacent, so 7 over x in this case. And now it becomes time for you to use your calculator and cross multiply until you can figure out what x is equal to. There's still a couple of steps remaining, and I don't want to give this answer away, so listen carefully for it, and you can rewind, of course, if you have to, for how to finish off the work. So once you found x, this is the height of the triangle, right? Here is, again, that full triangle with the 14 here. This height that I'm drawing in now is the x. So you find this as an answer, as a number, right? And that becomes the height. So then you say, well, what is the formula for area of a triangle? Base times height divided by 2 equals whatever, equals your area. And I'll simply say, to conclude this problem, that if this is the area of one triangle, look at your octagon and think for a second about how many triangles are actually in this figure. So you're doing this answer times something to get your final answer, your final total. On to page 2. Number 7. There weren't too many of you that missed this problem, I think for obvious reasons, as long as you grabbed the right formula. This was a very straightforward, old-style circle problem, nothing to it. Area, pi times r squared. You're given r, right? Circumference, 2 times pi times r. Round it off to 1 or 2 decimals, I don't care, and there's not much to that problem. Number 8. Okay, the part that a lot of you struggled with on this was you knew you were going to have some kind of an equation and it was going to equal a total, and the number for the total was all over the place. Some of you said 180, some of you said 360, others had different totals. Notice that this is a hexagon, 6 sides. So if I just take a moment over here and take that really easy formula for finding the angle total of any polygon. Remember, this had 6 sides, right? So I'm plugging in 6. That ends up giving me 4 times 180 for the total of this guy. 4 times 180 is 720. 720, therefore, is what goes on the other side of the equation. Then what I'll do is I'll literally add around all these angles, right? I'm adding all those together, combining them, and that will be the left side of the equation. Solve for x. Okay. This is the one, by the way, that I said would be an ugly decimal answer, unfortunately. Not terribly ugly, but it's just not a nice whole number, unfortunately. So anyway, here we go. Watch as I count around this, this figure. Here's 5x. 4x makes 9x. 5 more is 14x. There's 2 more is 16x total now. 3 more makes 19x. And finally, 1 more makes 20x. Just doing it in my head keeps me from having to write down every single thing on, and wasting my time, right? We can all add simple x's together like this. And now the numbers, plus 2, plus 6 more, that is a plus right there. Plus 6 more is 8. Here's minus 2 puts us at 6. 6 plus 5 is 11. And 11 minus 10 is positive 1. I know you all can solve this equation, and you see right away why you get a decimal. It's the stupid minusing 1 from both sides is going to make the decimal necessary. Anyway, you find out what x is, and it goes right in there. I remind you that on this question, not for the second part, for angle B, there's angle B's name. You've just figured out what x is, right? You should immediately know what to do to get angle B. But for this problem, ABG, ABG was meant to be this angle out here, the one that I'm putting a question mark on right now. It's an exterior angle, right? Exterior angle. So these two right here have a certain relationship. And again, you just got done finding out what this one is. So hopefully you can figure out what angle ABG is on the outside. Question 9. If the area of a circle is 36 pi, what's the diameter? We've already dealt with the area of a circle formula a moment ago, a couple questions ago. It was pi times r squared. I know a lot of you don't like it when these answers are left with pi in it, but I'll say again, it actually is easier to have pi in the answer than it is to not have pi in the answer, because then you have these ugly decimals if you just type in 3.14. Compare the left side and the right side for a second, please. Let me think about this. Pi times some number squared is equal to pi times 36. Doesn't that kind of say that, all right, look, the pi's already match. The pi's are already equal on both sides of the equation. So forget about those. R squared is 36. What number squared is 36? 6, right? 6 is my radius, the radius of this circle. And I now bring it to your attention that I'm asking you for the diameter of the circle. You should know right away the relationship between radius and diameter, and that problem will be done. Number 10. Kennedy High School has an academic circle with a radius of 75 feet. Radius from the center of the circle to the middle of the hallway. This question wasn't meant to confuse anybody. Some of you didn't like the middle of the hallway in the question. All that means is, look, here's the center of the circle, the circle of our school, which would be in that sort of empty space in that weird part in the middle of the circle that no one ever goes to. You can see it from the inside circle rooms, right? And then so the distance from that center out to the middle of the hallway where you have your passing time, where you walk from class to class. But the hallway is kind of thick, right? It's like 10 feet wide or something. So we just wanted to make it clear that pretend the 75 feet is from the center to the middle of the hallway. If you want to ignore that, go right ahead. Bottom line is this is just a circle with a radius of 75. And you, or Sam, excuse me, Sam's the person in this question, you're walking around this circle. fact that I just told you that should basically give you the answer to the following issue. Is this question about area or circumference? That matters because then you use one of these two formulas, right? So again, one of these is the appropriate one for this question, going around the outside of the circle. Enough said. Number 11. Maybe there were 3 people who got the perimeter part of this correct, so this was definitely a tough little question. And as you can see, we're almost done. Here we go. The diameter of the circle is 16 feet. Well, someone tells me what the diameter of a circle is. My first thought is just to go ahead and write down the radius. Maybe I won't need it, but probably I will, and it's good to just write down what it is. First thing, what is the area of the shaded region? So we come to the shaded region here. We did lots of these problems. This is called a sector of the circle, the colored in part. It's called a sector. And what we learned, right on the toolkit, was that if I could find the area of the entire circle, so here's my area formula at work once again, pi times radius squared. Okay, obviously this will equal something, right? But if I found that answer and I multiplied by the part of the circle that I actually care about, I don't want this part. I don't want the 80 degrees. It should be very easy for you to figure out what the rest of the circle is in degrees. Okay, so whatever you think that this shaded sector part is in degrees, put that on top right here over 360. So now to finish this off, you're going to find out what pi times 8 squared is. You're going to multiply by this fraction here. Sorry for the cursor being in the way. You're going to multiply by this fraction, something over 360, the shady part's degree measure. Okay, and you'll have your answer for the area. For the perimeter, it's very similar, except I don't want to use the area formula. I want to use the circumference formula. So again, figure out what this is for the entire circle.
Nikki Jordan, please come to the main office. Nikki Jordan, please come to the main office.
Sorry for that announcement, interruption. Anyway, circumference of the entire circle, multiply by the same fraction you did up here. So whatever you figured out this number to be, over 360, that's still the part of the circle that we care about, isn't it? And we'll get an answer. Now, this answer right here that I'm putting the star on, a lot of you filled in as the answer for perimeter. And you got 1 out of 2 points. Here's why. It says up in the question, what is the perimeter of the shaded region? Now notice this part. Think about this one. We are not just asking for the arc length, are we? Pretend that you were a little bug or something, and you started right here, and you were walking around the shady part. So I'm walking, I get right here, right? Well, to make it from where I'm at to the beginning, I still have to walk along this path, and I still have to walk along this path. And so that would be finally tracing all the way around the shady part. And almost everybody, congratulations if you got this one fully right, 2 points. Almost everybody forgot to add on those 2 extra steps right there. So please make sure you include those in your answer now. Tough problem. Number 12. Go from hard problem to a really easy problem. The 2 shapes below are similar. I know the area of the smaller one is 62. What's the area of the bigger one? We'll look at the numbers that are given, 4 and 12. How does one get from 4 to 12? What's the zoom factor? We used to call this the zoom factor. Well, obviously 4 times 3 is 12, right? The zoom factor is times 3. There were a lot of you that were doing like 8 you know, because 4 plus 12 is 8. We never add when we're talking about similar figures and zoom factors. It's always multiply. Okay? So the zoom factor is 3. But that does not mean that 62 times 3 is the answer that I'm looking for. Yeah, go away. I hate that one. 62 times 3 is not the answer for the area of the big figure, because we have to keep in mind that area involves the zoom factor squared. Okay, so these areas here didn't grow by 3, they grew by 3 squared. All of you can do 3 squared in your head, and that's how much the area grows by, that you can, for instance, write inside the shape or something like that to get this one correct. Last but not least, the one review problem on the whole test. And I think that a lot of you had a hard time, since there was no center drawn in here, you had a hard time kind of putting these 2 points in the right spot. -3, 7, 8, -3 comma 9 is right there, and 1 comma 2 is right here. Okay? First thing they want is the length of that line. Length of that line. Okay, come on folks, you made 100 slope triangles in your lifetime. Here's 101. And you count. This leg here is 7. This leg here is 4. Check your work. A lot of you have like 8 here or 5 there. You just miscounted or you misdrew the points. So if I want to find out the length of this segment here, Pythagorean theorem, 7 squared plus 4 squared equals c squared. And will you please make sure that you give me c, your answer, as some kind of a decimal? I mean, don't round that one off because it's not really a whole number. It's not a perfect answer. And finally, we come to our midpoint formula. This goes back just 1 chapter ago. So yes, it's review, but it's review from very recent times. Midpoint, you take the x numbers, see the -3 and the 1, the x coordinates, you add them together and divide by 2. And you do the same thing with the y's. Oh no, it looks to me like this one here, 9 plus 2 is 11. 11 divided by 2 doesn't exactly work out all that well. So what? You can handle decimals every now and then, right? But do this calculation. There's the first part of your midpoint. Do that calculation. Get the decimal like I said. And that's the second part of our midpoint. And that's all there is to it. That's the midpoint formula. Alright, like I said, rewind as often as you need to. Go back and forth through the video here. Watching and rewatching if you have to, and make sure that you do the very best you can to get the right answers down. You get half credit back for anything that you can fix. Okay? Thank you.